Welcome to The Explainer. You know, we usually think of AI as this one single super smart brain, right? But what happens when a problem is just way too big for even that one mind to handle? So yeah, that's the big question, isn't it? As we keep pushing AI, what do we do when one brilliant mind just isn't enough? Do you just build a bigger, more complicated AI? Well, no, not really. The answer is actually a lot more social. You build a team. Yep, it's that simple. Instead of trying to build one single super genius, you build a whole crew of them. And that's the core idea behind what we call multi-agent systems. I mean, just think about it. How would one AI manage something like a city's entire traffic system or a global supply chain? These things are just massive. So many moving parts, so much information. It's just too much for one agent. And this is where the term multi-agent system, or MAS for short, comes in. It's basically a system where you have a bunch of these independent, autonomous AI agents all working together, collaborating, to crack a problem that's just too big for any one of them to handle on its own. It's less like a single brain and, way more like a super efficient digital project team. Okay, so how does this AI team actually pull it off? What makes them a real team and not just, a bunch of random programs running at the same time? Well, it all boils down to a few key behaviors that let them work together. For any of this to work, these agents have to have a kind of digital social skill set. I mean, first, they've got autonomy, right? They make their own calls without someone holding their hand. But then they have to communicate, constantly sharing data and updates. They have to coordinate so they're not stepping on each other's toes. They even have to negotiate if they disagree on something, like who gets to use a certain resource. And all of this is pointed toward one shared goal. That's the glue that holds the whole thing together. A really good way to visualize this is to think of it like a digital assembly line. Let's say you've got a huge research project. Instead of one AI trying to do everything from start to finish, you break it down into specialized jobs for each agent on the team. So, first up, you've got your data collector agent. Its only job is to go out and grab all the raw, messy data from the web, from APIs, wherever. Then it passes that mess over to the data cleaner agent, which tidies it all up and gets it ready for use. From there, the analysis agent, kind of the team's data scientist, jumps in, runs its models, and pulls out the key insights. And finally, the report writer agent takes all that complex analysis and turns it into a summary that you and I can actually understand. See how that works? Each agent does its part and then hands off its work to the next one in line. But, and this is a big but, that whole process, that smooth flow, it completely depends on them talking to each other and coordinating. If one agent gets stuck or passes on junk data, the whole assembly line can just stop, deady its tracks. But of course, just like with human teams, right? Getting a bunch of powerful, independent minds, or in this case, AIs, to work together perfectly, well, it's not always that easy. And managing them brings up a whole new world of really interesting, really tricky challenges. Yeah, managing this AI team is a real challenge. I mean, the more agents you add, the crazier the coordination complexity gets. You'll run into resource conflicts when two agents want to use the same thing at the same time. All their back and forth can create a ton of communication overhead, just slowing things down. And sometimes you get these totally weird, unforeseen behaviors that just emerge from all their interactions. It all points to a massive headache when it comes to scalability. Let's take a super simple example of a resource conflict. Imagine your company has just one really powerful, super expensive GPU, okay? Well, Agent A needs it for a long, heavy training task, but Agent B needs that exact same GPU right now for some urgent data analysis. So who gets it? If they don't have a solid way to negotiate and figure that out, the whole system can just freeze up. So what we have here is this amazing divide and conquer approach for solving huge problems. It's incredibly powerful, but harnessing that power isn't as simple as just, switching on the agents and letting them go wild. When you boil it all down, it really comes to this, that divide and conquer superpower that multi-agent systems have, it comes with a huge catch. They demand really, really careful design. If you don't build a smart architecture for them to work within, you don't get collaboration. You get chaos. And that really leaves us with a big question for the future. As these AI teams become more and more a part of our world, what's going to be the real bottleneck? Is it going to be the raw power of the AIs themselves, or is it going to be our own ability to manage them effectively? Thanks for joining us on The Explainer.